Let's learn about the future technologies. Let's learn about the future. Welcome to Hyperfocused Engineer.
Picture two students with the exact same brain. Same smarts, same effort, same test on Friday. But one of them studies from a clean, correct textbook, every page crisp, every fact right. The other studies from a torn pamphlet, typos everywhere, whole pages missing, a few answers just plain wrong. Friday comes, one aces it, one bombs it. And here's the thing, the difference had nothing to do with how smart they were. It came down to one thing, what they were fed. Today that's the whole episode, because a machine is exactly the same. Last time we watched a model learn that guess, check the error, nudge downhill loop over and over until it fits. And right at the start, that first tiny model drew a line through house price dots. But we skipped a quiet little question the whole time. Where do the examples come from? What exactly are you handing the machine to learn from? Because a brilliant learning loop fed torn pamphlet data learns garbage beautifully. Garbage in, garbage out. The model is only ever as good as what you feed it. Let's put a name to what you feed it. Open the notebook. Draw a table, one row per house and columns beside it. Each column is a clue about that house, its size, its number of bedrooms, its neighborhood. Each of those clues has a name, a feature. A feature is just one column of information you hand the model. And here's the part people miss. The machine can only see the clues you give it. It has no eyes, no common sense, no walking past the house. If it isn't in your table, it doesn't exist to the model. You choose the clues. That's your job. So which clues should you write down? Not all of them earn their column. Add neighborhood, a good feature. Houses in a pricey part of town really do cost more, so that clue helps the line predict. Now add the owner's favorite color. Does purple make a house worth more? Of course not. That column is pure noise, random numbers with no pattern in them. And feeding a model noise doesn't do nothing. It distracts. The machine goes hunting for meaning in a clue that has none, and its predictions get worse. Good features sharpen the model. Useless ones just get in the way. Let's actually run it in the notebook. Start with just house size, the old dots and line we started with doing okay. Now ink in the neighborhood column. Watch the line tightens, the predictions snap closer to the real prices. A good clue and the model got smarter. Now scribble in favorite color. The line wobbles, chasing a pattern that isn't there. Same model, same learning loop. All we changed was the clues on the page. Now the scary one. Down on the table, someone fat-fingered a price. A house that sold for $300,000 got typed as $30. One dirty row. Watch what the fitting line does. It lurches, dragged way down toward that one impossible dot, and now every prediction is off. Because here's the brutal truth about a model, it can't tell a typo from the truth. It has no idea a house can't cost $30. It believes everything you feed it completely. One bad example and the whole line tilts. So here's the lesson, and it's the one nobody tells beginners. When your model is disappointing, your first instinct is to reach for a fancier one, a bigger, cleverer machine. Usually, that's the wrong move. Look at your data first. Add a clue that actually matters. Hunt down the typo dragging your line off. More data and cleaner data beats a cleverer model almost every single time. Better ingredients beat a fancier oven. Screenshot this. Features and data front to back. 1. A feature is a clue, one column you hand the model and it can only see the clues you give it. 2. Good clues like neighborhood help. Useless ones like favorite color are just noise that hurts. 3. Dirty data poisons everything because the model believes every number you feed it, typo and all. 4. Before you grab a fancier model, fix your data. Garbage in, garbage out. Better clues and cleaner examples win. Want real data to play with? Kaggle has thousands of free datasets, houses, movies, whether go poke at a messy one and feel it. StatQuest on YouTube breaks this stuff down with a smile and a song. And Google published their rules of machine learning, plain-spoken advice from the people who ship it, and rule number 1 is basically, good data beats a clever model. But here's the twist waiting next door. Even with perfect, clean data, a model can fool itself, memorize the answers instead of actually understanding them. Next episode, overfitting. Subscribe and let's keep going.